So for alkali metal, for group 7 halogens, we have fluorine, chlorine, bromine, iodine, and astatine. So for this group, you have to learn the states, the reactivity, the density. So for fluorine, it is pale yellow or light yellow gas at room temperature. For chlorine, it is yellowish green gas at room temperature. For bromine, it is red brown liquid at room temperature. For iodine, it is purple or black solid. And for astatine, it's also a black solid. So as you can see, when we are going down the group, the color is getting darker, means the elements, the color going down the group, the color is darker. And about the reactivity, so as we go down the group, you can see the reactivity is decreasing. Yes, you have to learn these colors. What about the density? Density means mass present in a unit volume. The first two are the gases, then it's a liquid, then solid. So what you can say about the density? So the density is increasing. As you can see, the first two are the gases, then you have a liquid and solid. So solid have greater number of the particle. So it become more dense, so density increases. And what about the melting point for this non-metals? As you can see, first are the gases, then it's a liquid. So melting or a boiling point. So as we go down the group, the melting or the boiling point will also increase. So these are the periodic trends which you have to learn. The color, the states, the reactivity. These periodic trends you have to learn or memorize. The colors, the states, reactivity, density, and trend in the melting point. And as we know that fluorine is more reactive than chlorine, chlorine is more reactive than bromine, bromine is more reactive than iodine. So always the more reactive halogen will displace the less reactive halogen from its compound. So the more reactive halogen displace less reactive halogen from its compounds. So example, if you have fluorine, which is F2, and how these elements exist in nature, because these are non-metals. So how these non-metal exist? So fluorine exists as F2. It's not like fluorine atom, it's F2. How chlorine exists? It's existing as Cl2. How bromine exists? Br2. How iodine exists? I2. Astatine exists? A2. So all of them in nature, they exist as a molecule or exist as diatomic molecule. Diatomic means Di means two and atomic is for atom. So there are two atoms in one molecule. That's why we call them as diatomic molecule. But in the periodic table, only the symbol is used. It's not how they exist. So it's in a periodic table for fluorine, a symbol F is only written. But how it exists in nature, it exists as a fluorine gas, which is F2. How chlorine exists in nature, it's not like Cl chlorine atom. It is chlorine molecule, which is Cl2. So always the more reactive halogen displaces the less reactive halogen from its compound. So what does it mean? Like example, if we have fluorine reacting with potassium chloride. So always the more reactive displaces the less reactive from its compound. So you can see fluorine is more reactive. So fluorine will displace or knock out this chlorine. So if fluorine will displace this chlorine, what will be the compound form? The compound formed is potassium fluoride. And what is the formula for potassium fluoride? Because potassium is group 1, so it is +1. And fluorine is group 7, so it is -1. So potassium fluoride will be Kf. Plus, as the chlorine is displaced, so it along with the chlorine gas, so chlorine will be Cl2. So you can see the more reactive halogen knock out or displaces the less reactive halogen from its compound. But this equation is not balanced, so then we have to balance the equation. First thing is completing the equation, and the second thing is balancing the equation. So how to balance this equation? As we can see, there is no oxygen or hydrogen, so we can take any other element. So fluorine is 2 here. So if I put 2, fluorine is balanced. And potassium, when I put 2, potassium is 2 here. So I will put 2. Potassium is also balanced. So this equation is balanced in terms of all of the elements involved. F2 plus 2 KCl gives 2F plus Cl2. That's right. But if the same reaction was chlorine was reacting with 2 Kf or potassium fluoride, what will be the product? That's right. There is no reaction. Why there is no reaction? Because chlorine, it will not react. There is no reaction. Why there is no reaction? Because you can see the order of the reactivity. Chlorine is less reactive, so it cannot displace or knock out this fluorine. So if it's not able to knock out the fluorine, there is no reaction between them. Or is it, it will remain as it is. No change, no visible reaction. Is it clear? So as we know, in terms of reactivity, fluorine is more reactive than chlorine. Chlorine is more reactive than bromine. Bromine is more reactive than iodine, and iodine is more reactive than astatine. As we go down, the reactivity decreases. Now you have to learn the observations as well, like what you will see or what you will observe when certain reaction occur. So example, you have a solution of potassium iodide. So you have aqueous potassium iodide. What's the meaning of aqueous potassium iodide? Means it contains potassium ion and iodine ion. Group 1, 2, and 3, if the substance is a solid, then it will be white. And if they are dissolved, then it will be colorless. So what is the appearance of potassium iodide in the beginning? Potassium iodide is colorless. Now, I bubble chlorine gas through it. Means I'm adding a chlorine gas. So when I add a chlorine gas, if I write this equation, chlorine plus potassium iodide, as we know, chlorine is more reactive than iodine, so chlorine will displace this iodine. So the result will be potassium chloride plus iodine molecule. The state symbols, chlorine is a gas, potassium iodide is aqueous, dissolved one we are using. Potassium chloride, which will also form, is aqueous, and iodine is at room temperature, it is solid, but iodine, because it is forming in the solution, so iodine is also aqueous or dissolved. So when we bubble this chlorine gas through a solution of potassium iodide, what we will observe, so we will observe that the solution will turn into potassium chloride, but again potassium chloride is a colorless, as I mentioned that group 1, 2 or 3, if they are soluble salts, they are colorless. So this is also colorless. But what it result, there is also another thing which is formed, and that thing is iodine. Iodine molecule is also present. And when iodine molecule is present or dissolved in water, what is the appearance of iodine? It depends on the concentration of iodine. So there are two possibilities when iodine is present. It can be yellow. Yellow means when iodine is a small amount, dilute solution is there. And it can be brown when it is a concentrated iodine. Like if too much iodine form, then the solution will be brown in color. If small amount of iodine form, then the solution will be yellow in color. So potassium chloride is colorless, but because of the presence of this iodine, what we will observe? We will observe that this solution will turn into yellow. So what is the observation when this reaction occurs? We'll observe that the colorless solution turn yellow or acceptable brown, because yellow is when it is dilute and brown is when too much iodine is formed. So depending on the amount of iodine formed in the solution. Is it clear? So you have to learn this observation when we bubble chlorine molecule, chlorine gas through a solution of potassium iodide. Potassium iodide, originally it is colorless. As the chlorine displaces iodine, it forms potassium chloride. Potassium chloride is also a colorless. But because iodine is formed and this iodine is yellow, so solution will not remain colorless. It will turn into yellow or brown. Is it clear? Any doubt in this part? What we get from this investigation or this reaction shows that chlorine is more reactive than iodine. If we want to practically show that chlorine is more reactive than iodine, if chlorine was less reactive than iodine, then there should be no reaction, or the colorless solution will remain unchanged, or it will remain colorless. So this investigation shows that chlorine is more reactive than iodine. Is it clear? So if I want to write an ionic equation for this, so you can see I will cancel out the common ion in aqueous. So when I cancel out the common ion, potassium is common. So I will cancel out. This equation was not balanced, so I put 2 here. So the ionic equation will be Cl2 plus 2 iodide ion gives 2Cl chloride ion plus iodine molecule. So you can see, we can also say the more reactive halogen displaces the less reactive halogen ion from its solution or compound. Is it clear, the idea? There are more examples I'll give, but less than a minute left for this session, so I'll share another link and explain more examples related to reactivity of halogens. Why we cannot cancel the iodine? Because here we have iodine molecule and here we have iodide ion. So you can cancel ion with ion, but you cannot cancel ion with molecule. So these two cannot be cancelled. That's wrong. If it was iodide ion, both